Hello, and welcome to the second part of our one variable statistic analyzer. So what we have in this spreadsheet is all the various things we've created up to date. Now in the end, after all this work and all this analysis, it comes down to what is the actual reaction time with its uncertainty. We've computed our one variable statistics. We have our upper limit, mean, and our lower limit, and our uncertainty, which is this number here, 61. So if we're going to express it overall, we start out with a mean. So that is going to be 371 plus or minus standard deviation, which is 61. And so that would at first glance, seem to be the case that that's our mean with its uncertainty. However, the problem is that our uncertainty can really only have one significant digit. If we're saying the uncertainty is on the order of about 60, then talking about the uncertainty also being in the ones place is beyond the level of precision we can actually report if we're saying the uncertainty is in the tens here. So the uncertainty should always be one significant digit, and that is driven by the standard deviation. And so really this number 61 should be 6 times 10 to the 1. That's how we would express it. So the number is like scientific notation. So what we want to do is express all of these numbers in scientific notation. And that's a simple formatting issue. We can add a column next to it, equals this number. And of course, it's going to give us the same number, and we can fill that down. But what we want to do next is format the number so it's scientific notation. Format, number, scientific. Now we said we want this 61 to be one significant digit. So that's going to help us determine the decimal place. So we've got 6 times 10 to the 1. And so you see that 6 is in this particular place, which means in the tens place, which means all of our other numbers need to be to the tens place as well. And that's because we are adding them. So in this case, we need to have two significant digits. And there we are. And then down here, we will have two significant digits. And so what we get is 3.7 is the mean. The lower limit is 3.1. And the upper limit is 4.3. So in truth, then, what we would report it as our value is 3.7. We'll put this in parentheses. 3.7 plus or minus 0.6. All of that times 10 to the second milliseconds. And so this is actually our final answer. 3.7 plus or minus 0.6 times 10 to the second milliseconds. We're saying it's about 370 milliseconds, give or take 60 milliseconds, or 3.7 plus or minus 0.6. And we see that borne out here in the digits above. Now, this mathematics here, the expression may seem a little bit complicated, but this wouldn't be so complicated if you saw the number 8 plus 2. Well, let's do it this way. 8 plus 2 times 10. Well, what do we have? We have, in this case, 8 plus 2 is 10 times 10. That is the plus part. And the minus part might be 8 minus 2 times 10. And so that is the plus. So it's 3.7 plus 0.6, or it's 3.7 minus 0.6, in which case we understand what to do with the mathematics here. We understand that this 10 gets distributed both to the 8 and the 2, and that we would add these first, but that we could distribute that through to get our answer. In any case, that's how we express our final answer.